Hello everyone, welcome to the Intelligent Oil and Gas Forum of this year's Huawei Industrial Digital Transformation Conference, with the theme of driving data to barrel, building fully connected, intelligent oil and gas. Having been affected by the continuing pandemic, the recovery of global economies and many other factors, digital transformation has become a must for oil and gas companies to develop in the future. During the process of digital transformation, data is at the core. How can oil and gas companies focus on data, enable data to generate more reserves and production, and fully explore data to increase business value? In this forum, well-known experts and scholars from the oil and gas industry will discuss these topics with all of us. Today, our first speaker is Saeed Al-Mubarak, Chairman of SPE Digital Energy Technical Section, and he will share his insights about digital technology trends in oil and gas sector. Welcome, Saeed.
Hello, everyone. Business value has already resulted from many digital technology implementation, but there are still many opportunities to be captured and many lessons to learn. Today, I have the honor to share with you some of the lessons learned from my journey in the digital world. I will share with you some important principles, concepts, and actual business stories, mostly in the upstream of oil and gas, yet very applicable to any industry. Nowadays, it is hard to attend a technical event without hearing a talk or having a discussion about digital transformation, artificial intelligence, machine learning, edge computing, digital twin, and others. It's due to the fact that they have great capabilities they introduce to create business improvement opportunities in the various domains, including but not limited to efficiency, safety, reliability, and productivity. I am Saeed Al-Mubarak, the chairman of the Digital Energy Technical Section and a consultant in petroleum engineering and intelligent fields. Well, during my journey in the digital world, I've learned that same ingredients do not usually yield similar results. Now, when it comes to technology, there is no one size fits all. And when someone is looking for a technology, it has to be a fit for purpose technology. So we need to know exactly where this technology is going to be applied. And we need to know their capabilities and their limitations and the uncertainties associated with them and with the environment that they will be deployed in. And definitely, we need to know not only the short-term application of it and even the long-term and their impact on the whole strategy of the implementation. Now, when it comes to the industries, they passed through three evolutions, and this is what you would be hearing about an industrial revolution, the first industrial revolution, the second and the third, be it from the steam engine to electricity to automation. And people now talk about more of digital transformation or the fourth industrial revolution, which is known more of IR 4.0. And what's in it? It's fusion of technologies and integration of the physical and virtual world to maximize productivity, enhance efficiency, and improve quality and reliability. And when it comes to real examples that we are witnessing today, I mean, we hear lots about smart cities, the e-commerce and e-government, and smart factories. And when it comes to the upstream of oil and gas, we hear about digital oil fields or intelligent oil fields. In a poll that I run lately on basically what industries that are more advanced in the digital transformation, is it really energy, healthcare and education, manufacturing, or automotive? And in fact, the poll came up with 47% staying or seeing the evidence of the advancement and the digital transformation in retail, finance, and logistics. It doesn't really, I mean, many of these companies are born digital, and this is why you've seen the advancements, and they're more of process-based with less uncertainty when it comes to it. Now, when we talk about smart X, this is a smart city, a smart factory, or e-commerce, or e-government. They don't only produce products. What they produce also data. And this data can be a product in itself if it is used to make decisions, and these decisions are used to make actions that add value. So in reality, or if you look at it, data by itself has inert energy. It's just like oil that's not really processed, it's underground. But if someone goes into this data, transfer it to knowledge, wisdom, and then use it to make accurate decisions for accurate and timely implementation, then this is where data can produce value. Now, when it comes to the oil and gas, I mean, this is more of just to share with you how the process goes from data. And in the old days, we kept talking about the production of oil from these wells. And if you look at it, we produce only, let's say, oil. But today, with the progress of communication, data capturing, sensing capabilities, and control capabilities, we have production also of massive amount of data. That doesn't mean that the oil and gas, from day one, they're producers of data. But now, this is an example, only one well, and this well produces oil, which has to go through processing facilities and processing plants to produce that oil, not only and process it to other elements. But what the data also is transferred through the field facilities, be it what sort of communication, wired or wireless, goes to the facilities itself, then into an IT infrastructure, and definitely this data has to be more of processed into visualization tools, systems and solutions, and maybe decision-making solutions as well. Now, this is more of a video that illustrates to you what we mean by digital oil fields. When it comes to the digital oil fields, I mean, we start with an intelligent well. And this well is equipped with sensors, controlling devices, and others. And it used to be that we look at wells, oil wells, as producers of oil. And nowadays, they're not only producers of oil, which is the product that we mentioned in the previous slide. It is basically a production of also data. And if you look at the infrastructure that's required to process the oil, you send the oil through the facilities, through the plants to process the oil. But when it comes to data, it takes another route, which is a bit similar, but through a communication means, be it wireless or wired, through the field, through the facilities, into the IT infrastructure of the company, and then it goes into solutions to make sure that these data are used after filtration and basically extracting the reliable data out of it to make visualization, to make decisions for subsequent implementation. And definitely on that route, you will hear lots of talks about cybersecurity, machine learning, artificial intelligence, and other aspects of the digital transformation. This is a very simplified definition or description of digital oil fields. And definitely there is no one size fits all. They are different in technologies implementation, and even in the processes and workflows and the business models. Now, when it comes to it, and to go a little bit further into one real example, but before I start with the actual example, let me share with you at least some description of how this, these wells look like. I mean, in the video, you've seen a multilateral well, and this is basically the picture that you see in the top left side, and it has 3 legs with the infrastructure at surface. In the right top side, you see the infrastructure subsurface, and that's the 2 kilometer or even more below the ground. And that infrastructure has more of sensing capabilities, and it has control capabilities. Now, what's associated with that infrastructure that is subsurface is basically our technologies at surface to make sure that we control the subsurface. We measure the production of the well by, let's say, surface hydraulic system that controls the subsurface valves, multi-phase flow meters to measure what the production of the well is, RTUs, SCADA, this is more of the IT infrastructure, and this is more of the ICV, the one on the left, the right basically of bottom right, the ICV and BDHMS, and the ICV is the inflow control valve. This is subsurface valve with different choke settings. And the PDHMS is a permanent downhole measurement system, which measures basically pressure, temperature, and in certain places, they have subsurface, even multi-phase flow meters. Now, let me share with you how this environment looks like. And if you look at the circle there, I'm basically identifying the places that I'll be talking about. These are the trilateral wells, basically laterals. And every single lateral, if you look at it, it's the box there. And every one of them has its own attributes that are different. So it has its own capacity. It could produce more. It maybe have different fluids. And the objective of the well, the total system, and consider it as a plant, is to produce an amount that determined by the manager of that well. And definitely there is not only one well, and there are different types of these wells, and the optimization has to go through these boxes to produce whatever your target is from that well or from that lateral. Now, this is an actual example that you may even read about in literature. And this is a well. And as you see, it has 3 laterals, A, B, and C. And every single lateral has a valve and has a measurement device. And now, if you look at the circle here, the orange circle, if it is fully colored, then it's a closed valve. And if it is just a circle, then it's open. And now we wanted to test this well. Because without the completion, without downhole valves, the well could not even produce because of the low reservoir pressure in that area. Now, we wanted to see where the water is coming from, where oil is coming from, and the objective was to produce this well only oil. We wanted to produce only oil. So what we tested first, lateral A, as you see, is a red circle, but half open. And it was producing only blue. And the blue, basically, column there is water. So the lateral A is producing, at that choke settings, water. Now, the rest of the laterals were closed. Now, we closed lateral A, we opened lateral B, partially open, and we closed lateral C, and it was producing only oil. And this is what we wanted. And now, we closed A and B, we opened C, it was producing oil and water, but at a different choke settings. It was so sensitive to the structure of the formation. There was a fracture, it was so sensitive to it. If you introduce a drawdown, a higher drawdown, you produce both fluids, you invite water to it. But if you restrict it, produce only oil. Now, we've done our analysis after testing several, basically, settings in the field. And we came up with the conclusion that we wanted to produce this well while lateral A is closed, lateral B is partially open, lateral C is a little bit restricted, and it was producing 6,000 barrels for 1 year and a half. And the well is still producing. It's more than a decade old. Definitely, we went through different cycles of optimization similar to this one. Now, if you look at what we've done basically in that well, and what I've shared with you is in a minute or two, this took us maybe 2 weeks. 2 weeks to calculate the data, to test the environment, test every single lateral, have these basically laterals and test tested accurately and reliably, and do our analysis. And this well is a system among many other systems, many other wells, and is associated with the strategy of the whole field. So we look at all the aspects for the lateral, the well itself as a system, and for the adjacent wells, and for the whole area, and for the target of the well and the area as well. Now, why digital oil fields? And there are multiple objectives, and there are overriding even objectives within the company itself with digital oil field implementation or without. Companies want to optimize cost, be it CapEx and OpEx. And this is, mostly pronounced in any company. And national oil companies might be different from international oil companies, but definitely they want to maximize also recovery or enable sustainability. And that's the confidence of the market on them. So the digital infrastructure is supposed to be fit for purpose, just like we stated in the tips at the beginning. And they need to use the technologies that basically bring value to the field. Now, uh, there were studies on where the value is obtained or where the maximum value comes from. And as you can see here, this is one of the studies that benchmarks 14 companies. And it seems to be that the predictive operations brings the highest value out of the data. And now when it comes to it, that doesn't mean it is the only one and you will go directly to predictive operation. You will not be able to go to it unless you have the infrastructure that is reliable, and you will have to have data that is managed, stored, and again is reliable to be able to use these data to come up with informed operation and predictive operation, utilizing the capabilities, the domain experts, and maybe the data science capabilities within the company, or even outsourcing it. Now, all of these processes and all of these analysis go through the fundamentals. I mean, and this is exactly what any business is doing, is they go through the data acquisition and learning from that data, going through the analysis, decisions, and action. And that's just the normal flow of decision making and action implementations. And now, what technology has brought to us, other than going through the cycle, which is the fundamental, it reduces the time required to close that cycles from information to action, to implementation. And definitely there is a value of time there, be it in the safety issues or critical issues, operational issues in the field. And technologies definitely have shown value when it comes to their successful implementation. Now, but we need to make sure that at least we understand and what real time basically means to us, and definitely these technologies would help us close the loop faster. But we need to understand what loop we are talking about, because knowing what the requirements are to close a certain loop would basically is directly connected to the capex and opex of these environments. So when it comes to operations, just like geosteering or optimizing artificial lift system, they're more of they're done as a fast loop. You can describe them as a fast loop where decisions can be taken in a quicker base, while the optimization of a production of a well, just like the well that we described earlier, and the actual example, took us 2 weeks. And that's really the time that is required to make that optimization and to get all the information that is related to the well and the surrounding wells and to the whole field. And definitely there will be more value if one can come up with processes to expedite closing that loop. And definitely when it comes to history match and simulation modeling and conducting prediction analysis, it takes a little bit more time because things have to be considered other than the actual environment of the field or the well. It's more, you look at strategies, oil price, and other things as well. But definitely quicker decisions that are really accurate may provide a better value for certain loops. Now, reality check, and we have to set our expectation right, and we have to know exactly what the business needs are. Now, when it comes to the oil and gas, just like any other industry, the assets get maturer, they get older, and when they get older, when it comes to oil, you lose production capacities and capabilities. Maturing fields, then you need more maintenance. And now with the implementation of technologies, when you have more technology implementation, one would expect that you would need more of these technologies to be reliable. And for their continuous reliability, you have to have a maintenance program that's really robust to make sure that they're reliable. And you have to have a strategy for implementation of new technologies, because technologies get obsolete and new technologies get introduced. But definitely any of them has to be, again, we go back to the tab, they have to be fit for purpose. Now, when it comes to the environment, you see many discussions about sustainability, CO2 emission, and others. And definitely these are concerns that the system the whole system needs to take care of these concerns and make sure they're considered. Now, in another poll that we conducted, and why many digital transformation projects fail, and these are more 4 items or 4 causes of that failure. And when you look at the feedback from most of the experts, and this is a 33% out of the voters, indicated that most of these projects don't really yield the value that the expected value, and this is why they fail. Well, definitely these basically causes of failure are all real, but the emphasis on real value, and this is why we need to focus on the objectives of these implementation, be it a short term and a long term, and make sure that they bring value at the end. And definitely certain entities within an organization, just like R&D, are allowed to fail because they are more of research and development and trial testing. But the key there is when you implement with the big vision, and when you are successful, you create the greatest momentum to scale up. And definitely the value comes from scale up, not from piloting. Now, what are the enablers of successful digital transformation? And this is more of a list, and they're not the only ones, but they're more of the prime ones based on my research and based on my experience. It's basically the infrastructure has to be really robust, support from all directions, top down, bottom up, sideways, from management, from data scientists, from domain experts. And there has to be some sort of incentive program to all those associated in the mission. And that has to be a clear vision to all, and that's transparent and shared with all the stakeholders. And that will bring more of the innovation cycle to become even quicker. People are incentivized, people are supported, and definitely they'll come up with ideas to improve their environment. Education is a necessity. Now, if we spill out what these 6 ingredients have, or enablers, they're more of summed up into 4. I mean, they're the technologies, and that's the infrastructure and support. The business environment, that take care basically of the communication, transparency, and support. Processes, and if you have a clear vision, then you know where you're going. And if you have uncertainties, this uncertainty gets less with time. People are really important. You have to educate them. They're the ones who are picking what technologies, improving what technologies you'll be using, and where they fit, and what value they can bring. So if we sum them up into the 4 enablers, they're enabling technologies, business environment, optimization processes, and people. And if you look at the right side, and these are the spheres, they're representation of the value of these, the investment value of these enablers. But if you look at it, so the bigger the sphere, the bigger the investment size. But if you look at it from a different perspective, you will see that the greatest value as per the x-axis comes out of people. So the focus on people, they're the ones who are picking technologies, they're the ones making up the environment, and they're the ones creating or coming up or improving the existing processes. This is the end of it, and I'm sure you got the message out of this interesting video. Thank you very much.
Thank you for Saeed's great opening speech. And next, I'd like to introduce Li Yangming, Chief Representative in Oil and Gas of the Huawei Global Energy Business Unit. He'll bring his insights about digital foundation to empower Industry 4.0 for oil and gas. Welcome, Mr. Li.
Distinguished guest, it's a great honor for me to present at HIDT. I worked for CNPC, China National Petroleum Corporation, for nearly 40 years and deeply participated in the digitalization process as the chief IT planning expert and IT director. Fascinated in its technology culture, I decided to join Huawei last year. Huawei is a leading global ICT product and solutions provider. To Huawei, Oil and gas industry is always one of the most important markets, and we have been constantly trying to understand and analyze the major business demands and the challenges of the oil and gas industry. Today, on behalf of Huawei, I'd like to share our thoughts on how Huawei could contribute to oil and gas industry's digital transformation and accelerate the journey to enter Industry 4.0 era. I believe we are all aware that not just oil and gas industry. The full human society is running into a new age, the digital world. From new business such as OTT, over the top media service, ISP, internet service provider, to traditional industries, for example, agriculture, construction, and of course, oil and gas. From serious consulting results, we could see the digitalization of oil and gas is developing, but it rather fall behind the position compared with others. There are multiple reasons to cause such reality. Today, I will focus on why oil and gas industry urged to accelerate digital transformation, how we can proceed with the strategy, and what capabilities Huawei could actually provide to support oil and gas industry in this journey. Firstly, why digital transformation? There is no doubt that our industry has been into a completely changed landscape. The COVID-19 induced recession has resulted in the sharpest downturn in energy and oil demand in living memory. On the bright side, the baseline is still solid for oil and gas industry. The global economies in 2045 will be more than double the size it was in 2019. But the changes are far more than that. Oil peak demand, renewables, and Paris Agreement. For example, China has announced that by 2030, it will reduce carbon emission intensity by 65%, and the share of land fossil fuel in primary energy consumption will increase to 25% by then. Furthermore, targeting net zero emission by 2060. These changes have introduced two challenges for oil and gas industry. How to produce using crude oil and refined products at a lower cost to stay competitive. Improve performance, accelerate first oil and gas for green assets, or prolong the life of mature ones. It may be the most important one for the coming years to meet environment regulations. Facing these challenges, major NOCs or IOCs made the same choice. Take digitalization as the key to the next chapter of this industry, a substantial and greater business. Especially when the advancement in technologies, the falling cost of digitalization, and the ever-widening connectivity of devices provide a real competition-beating opportunity to oil and gas companies who play the digital revolution right. When we are committed with the transformation, the methodology is far more important than technologies only. Based on Huawei's own digital transformation practice and our collaboration experience with customers from oil and gas industry, a quite universal methodology has been proposed to support oil and gas companies' digital transformation. It is summarized as one vision, strategic commitment of the CEO, two drivers, business and technology, have to collaborate together to drive forward. Three key processes: integrate planning, building, and operating. Continuous optimization. Planning, one top-down framework or blueprint to mapping the digital transformation of the full organization. It includes all business sections, workflows, and Meanwhile, focusing on quick win scenarios to add value. Then proceed with the process with continuous building and operating. Two guarantees are the digitalized preparation for the organization in manpower. The last is our digital foundation to support all the above in the key enabler to initiate the digital transformation of oil and gas industry. This digital transformation includes our aspects: ubiquity, connectivity, digital platform, data enablement, and artificial intelligence. In the next slides, I'll give a brief introduction about how Huawei can contribute to each aspect. First and foremost, the ICT infrastructure. Huawei is the world's leading ICT product and solution provider. This is what we do for decades. Huawei mainly provides network connection, IT infrastructure, and platform. As we are talking about the enterprise digital transformation today, I would like to discuss more on the new generation of campus network Huawei offered. Generally speaking, Cloud Campus 3.0 can help enterprise building a fully wireless campus network, supports cloud-based management and control platform. The system supports elastic scaling and can provide concurrent management of a maximum of 200,000 NES. Huawei's leading SRv6 technology allows campus networks to access into the cloud in one hub, greatly simplifying enterprise networking. The SD-WAN intelligent traffic steering technology effectively improves link utilization by 40%. Huawei provides the industry's unique 16-to-16R AP device, the Air Engine A760, to help enterprises achieve fully campus coverage without dead zone. High capacity can guarantee service. PPC, hybrid copper fiber cables, deliver ultra-large bandwidth, one-time deployment, stable running for more than 30 years. A use case here is for the Transneft oil company in Russia. Evolutionarily promoted its enterprise network service in the stunning new headquarters Evolution Tower. In order to support a business thrive, Transneft needs a complex network infrastructure. For new 55-story building with up to 10,000 users, build a highly reliable network for service for top management staff, and satisfy strictly security policies. Huawei's Campus 3.0 solution provides a reliable and well-scaling network, which allows business growth for the next 5 years. In the automation of operation and maintenance, reduces the time to launch new services from days to minutes, as well as lower OPEX up to 30%. Now let's discuss the digital platform. We all know the oil and gas industry is definitely facing great challenges, which requires us to accelerate EP process, further promote the CapEx OPEX execution efficiency, protect our profitability. However, when we take actions, there's serious challenges, just like Arduino's mega 3D seismic project. China's undertaking huge-scale 3D seismic activities too. We know that while huge seismic survey workload is ongoing, huge amount of data are generated by petabyte. The follow-up 3D seismic processing, high-resolution GNG modeling, and reservoir simulation. In the big data, AI applications require superpower computing capabilities and ensure high precision. Meanwhile, the data security is always a vital concern for oil and gas companies. So in this case, the dedicated cloud is designed to fulfill these requirements, which provides elastic computing power in cloud services while we mean data security regulation at the same time. In CNPC's famous Darting oil effect, by adopting Huawei Cloud Stack Online solution, their seismic data processing capability has been promoted by 5 times, from 400 square kilometers to 2,000 square kilometers annually. Moreover, cloud solution turn CapEx into OpEx, greatly reducing the client's initial investment. The total cost over 3 years was saved by 20%. Like I just mentioned, it's one of the largest crude oil producers. It's targeting on promoting its reserves in production to meet world's increasing energy demand and maintain its own business sustainability. Their choice of Huawei HPC has already supported to improve 45% performance in reservoir simulation, while support 5 years computing evolution. For traditional industries, especially oil and gas, which has long history in long value chain, the data integration and governance is always a top pain point. Dayu is Huawei's intelligent data lake operations platform solution to solve this challenge. Dayu was a legendary king in ancient China who was famed for his introduction of flood control. He figures in the Chinese legend of Great Yufu controlled waters. Data Lake Pool supports closed-source query of multiple data sources in online API generation without coding. The unified data platform we propose will, first, provide long-term secured and future-proof solution. The second, provide a single point of truth environment for the technical domains in the company. The third, assessment to connect all and collect in all for each of data sources and interface in or transfer current data sources with the company. The fourth, provide a comprehensive and proven solution to manage and enhance the data quality. The fifth, provide reliable and consistent facilities to have control over the updating of data sources. Specifically for Huawei Cloud, how it provides the AI capabilities, I will give a general introduction by the slide. Foundation level is the data. Once the data collected, streaming into our system. We can use our computing power based on the AI chips and other hardware, then to release the capability of our own deep learning or machine learning framework. It has 3 parts. The CNN is working like the bridging part between the framework and the hardware, so it's more like operation level. Once we get into the framework, let's MindSpore could analog to TensorFlow by Google or PySpark by Facebook. The training framework is where the developers, for example, the programmers, to use the language like Python to write programs. Then on the top level, we will see model arts in knowledge graph. What's model arts? Basically, it's a tool to make model developing easier. We just talked about MindSpore, which you can actually do the programming, but it's not really a general user would like to use. Because simply most of the people, they don't know how to program, and it's a high learning cost technical. So model art is the solution to provide predefined algorithms. With it, you don't have to write the program by yourself. Also, it makes model deployment much easier. By the way, model art not only supports the MindSpore framework, but also TensorFlow, MasterNet on the market. Knowledge graph is conceptually similar with model art. It will support users to use knowledge. For example, Huawei supports CNPC built its connective computing platform. 5 applications were selected for the first batch deployment, including logging interpretation, settling process in interpretation, where performs analysis in the palm status diagnosis. This AI application significantly reduces manual effort, promotes both efficiency and effectiveness, and enables predictive maintenance for logged palms. Out of the POC, CNPC estimated the total annual gain will be over $60 million by a full deployment of only these 5 applications. Last but not least, there's one thing for sure: we can rely on AI in cloud, IVS. The intelligent video system, with the increasing HRC requirement to oil and gas industry, IVS has already been a mature solution to support the 100% HRC philosophy. Simply speaking, the technology evolution has updated our current surveillance system from I can see to I can see clearly. And furthermore, the IVS can see it clearly and know what happened, who's involved, and what to do next. For Huawei, together with clients and partners relying on the accumulation of a high-speed network, our AI chips, edge computation platform, and solid algorithm research capabilities to provide an integrated HRC solution with high-definition cameras and intelligent systems. Huawei's smart gas station solution provides integrated end-to-end services, including smart customer services, smart station management, and smart marketing sales in different scenarios at the gas station site. All scenario realizations are based on Huawei Station Fusion platform, our build, which integrated with the modules of computing, storage, network, etc., providing robust integration of IoT, AI, and application enablement with unified intelligent operation and management. Innovative cloud edge collaboration enables fast development and smooth evolution. 5G SD-WAN improved quality of network connection with lower cost. Huawei's smart gas station solution is dedicated to build a future gas station ecosystem of people, vehicles, and services. Facing a challenging new era, it will not be easy. Just like conquer the Everest and reach the peak, based on our technologies and solutions of ICT and infrastructure, big data, cloud, and AI to support oil and gas companies achieve the strategic targets in the full value chain. Huawei is committed to the digital transformation journey, together with oil and gas operators and service partners. Thank you.
Thank you, Mr. Lee, for your excellent presentation. It really brings us a lot of new ideas for empowering Industry 4.0 for oil and gas. And now let's welcome Xin-Jun, Vice President of Development Research at CNPC's International Natural Gas Technology Center, to find out his opinion about data to barrels and the intelligent ESP management platform.
Hello, ladies and gentlemen. My name is Xin-Jun from CNPC. It's a great honor for me to give you the presentation. The topic is Intelligent ESP Management Platform. ESP is the abbreviation of Electric Submersible Pump, which is widely used in oil production. Based on our recent several years' experience on this field, we have made some progress I would like to introduce and discuss with you today. Nowadays, most oil field has realized basic digital foundation. Generally, most information generated from E&P activities has been digitalized. However, when we are entering the fourth industry age, digital transformation is far beyond the digitalization, especially in the production and the operation. Real-time data acquisition, integrated asset optimization, real-time collaborative working environment, digitalization of the workflow and the business value chain are the main focus for the next stage. The general information of our target is as follows. It is located in Iraq, was discovered in 1970s, and the production commenced in July 2011. Exceed 400 wells drilled in the oil field, including 250 oil producers, out of which more than 80% of the producers have been installed ESP, account for up to 85% of the field total oil production. All producers will be equipped with ESP in future. So ESP management is very important in the oil field. Unfortunately, we encountered challenges during the production period. From 2012 to 2019, exceed 300 times of ESP failure happened, which led to 11 million barrels production loss cumulatively, less than 70% overall ESP wells opening rate, which significantly impact the system efficiency and field sustainability production rate. Also increase OPEX of ESP operation and management, and exceed 600 barrels per day production loss per well during shut-in. So ESP operation and maintenance is the key for the oil field sustainability. In order to overcome these challenges, together with Huawei, we proposed the AIoT framework for the intelligent oil field upgrade. From the device and edge, deploy smart gateway to unify the data acquisition from different devices and build the bridge between center and edge. This connection is based on solid network infrastructure, the suit-for-purpose hybrid network solution. And for the well site without power supply, we have designed a one-stop solution, which I will introduce further in this presentation. The destination of data streams is our cloud platform, which will provide the capabilities of big data, IoT management, and AI, together with a bunch of industrial partners to develop and deploy the intelligent applications for different scenarios. Today, I will focus on our intelligent ESP management and an example to show how this structure works for us. Comprehensive monitoring and diagnosis indexes for 4 aspects. First one, well production performance, ESP operation conditions, fluid PVT properties, and reservoir geological characteristics. Equipment easy connection, real-time acquisition, all-time and all-weather management. Big data statistical analysis is carried out to monitor the production and the operation status of ESP wells for 24 hours. At the same time, it also supports the import of multi-format offline data documents. The data display forms are rich and diverse, and the data statistics are comprehensive and detailed. Comprehensive use of expert experience and AI technology. First one, on the basis of extracting the traditional experts' cognition of ESP fault knowledge to form the expert knowledge database, combined with the AI anomaly detection model, fault classification model, and self-learning mechanism, and through the rich logical relations that can be dynamically configured, the intelligent early warning and diagnosis of ESP production anomaly is realized. make full use of new technical means, big data, cloud computing, and AI, we realized closed-loop automation for ESP operation and maintenance. It means realize the online ESP management, realize equipment failure prediction through abnormal data analysis by the model, and raise treatment for abnormal condition of ESP wells. Guarantee the normal and stable production of the ESP well and reduce the operation and maintenance cost effectively. Current solution realized machine learning model realized continuous monitoring of the ESP status for full field, alarm and investigation tool that helps engines make early detection and rapid diagnostic of failure. The value added in current state includes first, 2 weeks to 2 months prediction prior failures. Second, 30% decline in ESP technical failure. Third, cost annual improvement from OPEX reduction and production gain. However, there are still remaining challenges to further promote the solution value. First, upgrade ICT infrastructure on field to support real-time data acquisition and unmanned operation. Second, unified AI platform to enhance big data to AI with advanced AI services. During the platform development, we have encountered a series of challenges. The most important one is real-time data acquisition, especially for the pump electric injector. In this case, Huawei proposed its all-in-one intelligent well solution, which could solve the bottleneck foundationally. It integrates power supply, network solution, IoT gateway, and edge computing in one station, could fully support current real-time data transmission and future edge computing implementation. Furthermore, the intelligent camera integrated can enhance the HSE by computer vision and AI technologies. In last year, Huawei has supported CNPC build the company unified AI platform. 5 applications were selected for the first batch deployment, including logging interpretation, seismic process and interpretation, well performance analysis, and pump data diagnosis. These AI applications significantly reduces manual effort, promote both efficiency and effectiveness, and enable predictive maintenance. In the next step, we will focus on expanding the utilization of AI to field production and operation. For example, intelligent well modeling and production forecast, virtual metering, integrated asset operating, drilling and fracturing automation, and so on. All these scenarios require the most advanced ICT solution to integrate all current available database. By leveraging the latest AI innovation to boost up system integrity and productivity. My presentation is over. Thank you for your attention.
Thank you, Mr. Xin. And now let's move on to how Huawei next generation storage for HPC advances oil and gas exploration, which is from Lai Nenghe, Chief Professor from the Geophysical Research Institute, BGP, China National Petroleum Corporation. Welcome, Mr. Lai.
Hello everyone. Today I'll be discussing Huawei next-gen storage for HPC advances oil and gas exploration. I'm from BGP, China National Petroleum Corporation. BGP is a multinational geophysical solutions provider specializing in seismic exploration in the oil and gas industry. The company's operations cover seismic acquisition, data processing and interpretation, equipment manufacturing, and software development. I've been with the company for over 38 years and personally been involved in HPC data processing, software development, AI informatization, and data center infrastructure. Today, my presentation shall consist of 3 parts: new challenges in oil and gas exploration, Huawei's solutions for coping with these challenges, and best practices. The oil industry chain is divided into 3 parts: upstream, refining and chemical processing, and sales. Throughout the entire chain, oil and gas seismic exploration is found in the most upstream section, playing a crucial role and adopting many advanced technologies. What is oil and gas exploration? It's a series of activities related to geological surveys and geophysics that are performed to identify oil or gas exploration areas and reserves. The exploration involves 3 main phases. First, acquisition. During this phase, seismic waves are manually created and underground signals are returned to generate field data. Second, processing. HPC systems are used to turn the acquired signals into data volumes that indicate underground tectonic features. Third, interpretation. Experts analyze and study the data volumes to locate oil and gas accumulation areas and advise on drilling points. Simply put, oil and gas seismic exploration is like a CT scan of the Earth's surface. What are the challenges of seismic exploration? As seismic exploration goes deeper, geological conditions are increasingly complex. This means oil and gas companies require more advanced exploration technologies. The most widely used are high-density, wide-azimuth, wide-band technology, high-efficiency acquisition technology, and high-precision seismic imaging technology. However, these technologies are leading to computing power shortages and higher storage requirements. In addition, the equipment used at different data centers was deployed in different phases, causing limitations on system scalability and preventing the system from effectively processing mass data. Here are some examples. Different imaging algorithms such as PSTM, WEM, PSDM, and RTM differ in terms of map quality and compute resources. The CPU compute time required by PSDM is 2.5 to 3 times longer than that needed by PSTM. The compute time required by RTM is 7 to 10 times longer than that needed by WEM. Even when using the same algorithm with different parameter settings, the compute time required to generate tectonic maps varies greatly from VTI-PSTM and TTI-PSDM to ORT-RTM, potentially taking between 3 and 15 times longer. Today, high-density, wide-azimuth, wide-band acquisition technology produces clearer maps than common technologies. The new technology has become a main trend among oil and gas exploration technologies, but also poses new challenges to computing and storage. Here are a few examples of tender projects we participated in from 2019 to 2020. As you can see from the last column in the table, mass data needs to flow through dozens of modules for processing, which can require 10 to 15 times more storage than the raw data. In 2020, a data center hosted 45 projects where the raw data volume was 1,616 terabytes, but the required storage capacity was 24 petabytes. Another center hosted 35 projects with 1,605 terabytes of raw data, but 24 petabytes of required storage capacity. Some other data center has added 32, 43, and 74 petabytes of storage in 2018, 2019, and 2020, respectively. How is Huawei dealing with these new challenges? First, Huawei provides high-performance, professional storage that offers high bandwidth, concurrency, and capacity. This storage has 5 key advantages: scalable architecture, dedicated hardware, efficient algorithms, open solutions, and an optimal business model. Second, Huawei adopts highly scalable storage with elastic architecture and symmetric interconnections for on-demand expansion and use. Performance grows linearly as capacity can be expanded on demand in just minutes. Huawei's unique info-turbo technology uses the intelligent prefetching algorithm to implement zero-copy design on the I/O path. Multiple technologies such as SMB multi-channel are applied to large file reads-writes. Third, Huawei adopts easy-to-manage intelligent storage that offers simplified configuration, supporting intelligent O&M, optimization, and management. Huawei manages storage systems at 3 layers: device layer, data center layer, and off and on-premises cloud. These 3 layers are integrated to achieve efficient O&M. At the device layer, Device Manager enables intelligent management and simplified O&M. At the data center layer, Huawei Ocean Store DJ software is used to manage the entire lifecycle of data center storage. At the off and on-premises layer, Huawei e-service software automatically reports device information to the cloud. The cloud then uses online training to provide intelligent decision-making suggestions and pushes them to local devices, implementing AI collaboration both on and off-premises. Seismic data processing heavily relies on bandwidth and concurrency. Typical requirements are as follows. The computing power of a single node must be greater than 1 teraflops. The read-write bandwidth must be greater than 1 gigabyte per second. A maximum of 20,000 instances can be concurrently processed. The latency must be between 200 and 400 microseconds. Huawei's typical solution meets all of these requirements. The solution consists of 3 parts: computing, switching, and storage, including online and backup archiving. Huawei's typical solution has 128 nodes and 1 petabyte of storage. It features high bandwidth, high concurrency, high reliability, easy management, and flexible scalability, offering computing power that reaches 149 teraflops. The read bandwidth reaches 33.9 gigabytes per second. The write bandwidth reaches 35.1 gigabytes per second, and the latency ranges from 200 to 400 microseconds. It can also be scaled to 4,096 nodes. Therefore, Huawei's high-performance NAS storage solution for full-stack mass data processing can fully meet the requirements of oil and gas exploration. In addition, Huawei's next-gen Ocean Store Pacific uses an ultra-high density design to condense multiple cabinets into one, lowering TCO. Ocean Store Pacific provides multi-protocol interworking capabilities for zero copies throughout the entire process, improving process and storage efficiency. Ocean Store Pacific also provides a hybrid load design. One storage system can meet needs in different phases. How do we use this solution? Let's take a look at some specific application scenarios. For example, 3 storage nodes, 8 compute nodes, and 16 threads are deployed in this scenario. The bandwidth of each storage node reaches 2 gigabytes per second, which can meet the requirements for seismic data processing. We know that QPSDM has better imaging performance than KPSDM, but requires more compute time and higher storage performance. In this example, we use 6 144 terabyte NAS disk arrays and Huawei 1 petabyte parallel storage to run the compute-intensive algorithm QPSDM. As shown in this figure, Huawei parallel storage CPUs provide much higher operational efficiency. This is an example of PSTM. We know that PSTM has better imaging results and has become a routine process. However, it requires very long compute time and typically uses CPU plus GPU heterogeneous computing, which requires high storage concurrency. On the left is one brand of storage. On the right is Huawei's parallel storage. We can compare these two brands' efficiency when running PSTM. The monitoring software shows that running efficiency is vastly improved with Huawei storage. Huawei's high-performance parallel file system significantly improves the concurrent processing of mass data. The figure above shows the read and write bandwidth of 6 petabyte OceanStor 9000 while running 1,000 seismic processing jobs. We can see that the bandwidth can reach 13 to 14 gigabytes per second. The figure below shows 500 concurrent processes on the storage system handling reads and writes and multi-user interaction. CPU monitoring data shows that the CPU usage reaches 60%. Huawei provides customers with more solutions and flexible business models to build private clouds and on-premises clouds. This is a Huawei cloud computing platform built for a large oil field in China. The platform uses 12 petabyte Huawei storage to provide the oil field with data processing and interpretation services. The oil and gas industry has undergone sweeping changes, resulting in new challenges such as mass data processing, high-precision reservoir modeling, data governance, collaborative research, and independent workflows. The development of next-gen IT and digital technologies have led to requirements for the application of high-precision geophysical algorithms, superb computing power, high-performance storage, and powerful AI. Therefore, customers in this industry need to improve quality and efficiency, centralize IT infrastructure resources, and accelerate enterprise migration to the cloud to reduce the amount of investment required. The IoT, 5G, cognitive computing, and AI will facilitate the digital transformation of oil and gas exploration while accelerating the development of digital basins and smart oil fields. That's all from me. Thank you.
Great topic from Mr. Lai. Thank you very much. Lastly, let's warmly welcome Lu Guanghui, Senior Technical Director from CNPC Kunlun Digital Technology Corporation, to share his insights on data lake and integrated application.
Hello everyone, my name is Lu Guanghui, Technical Director from CNPC Kunlun Digital Technology. I'm very happy to attend Huawei Digital Transformation Conference. Today, my topic is data lake and the integrated application. 3 outline. The first one, data lake construction. Second, integrated application. Last one, way forward. After more than 10 years efforts, CNPC already combined the A-series database plus the self-built data system from different oil companies to build the data lake. So currently, the content of the data lake, including master, metadata management, quality assurance, data integration, and security management are developed to establish unified data services, which is based on the exploration and production data model of CNPC, and using the data lake technology to accomplish unified management, governance, and shared application of the whole upstream business data. Currently, our data lake already covers 4 work environments. Data input mainly provides a stable, secure storage and management environment for both structural and unstructured domain data. The data governance mainly supports upstream business data governance system and provides a governance service environment for master data, metadata, data flow, and quality control. The data service mainly establishes the one-stop service environment for EMP whole business chain data. The big data analysis mainly supports parallel computing and high-speed searching and provides convenient data environment for big data analysis and cognitive computing. Till now, we already use the different open source technology to develop our data lake. Till today, our data lake already collects the more than 500,000 wells, 800 plus reservoir models, and the 7,000 plus seismic survey, covered the 16 oil field subsidiaries. The total volume of the data set reached 1.6 PB, mainly covered three types of data: structured data, unstructured data, and high-frequency data. As we all know, the final aim is not just the data lake construction. Our real final aim is how to use data lake to support our integrated application. Today, our unified data lake, which supports unified technical platform, integrated application, and standards, specifications, data lake and the technical platform are the base of integrated application, standards, and specifications. Till now, we already achieved good results based on this whole solution. The second, the integrated application. Currently, our data lake and the technical platform already provide us the integrated application. Based on the unified data lake and the technical platform, we already covered the 4 parts. The first one, exploration, appraisement, mainly focus on the operation of exploration and evaluation, and enable the collaboration between mineral reserves, geophysics, and wellbore engineering. The development and production mainly focus on the oil and gas production, and enable the collaboration between front-end production, back-end management, and decision-making. Collaborative research mainly focus on the comprehensive research, enable the data and research result sharing, software and application integration, and multidisciplinary collaboration. The last one, operation management. Just because of the time limitation, so here I just share the 2 case studies. The first one, the well planning, how to do the decision making for well planning. This is the case in the online collaborative well planning workflow. Based on the multi-map linkage, well planning is accessed using multidisciplinary results such as different domain data, like geological map, seismic section, reservoir model, and so on. According to this picture, currently, if the engineer do the well planning, they can automatically, quickly, to extract any data at any time. For example, the sand isopatch, reservoir isopatch, porosity and permeability of the reservoir, surface topographic map, and the seismic data in the 3D window or 2D window, also the 3D reservoir model. But originally, all these jobs are very time consuming. Today all these jobs we can do it automatically and quickly. Currently, based on the data lake and the technical platform, we provide web-based interface for the EMP data analysis and display. Today, the well planning engineer quickly access and display the point, line, map, section, volume, research data in different domains to analyze the well location and adjust it in time to improve the efficiency of comprehensive research. You can see this picture. The background is structure map. For the well planning engineer can click any well position to extract any information from the well borehole. For example, the well log information, the well profile comprehensive, and the core data from borehole and the reservoir section which is related to this well. For the well planning, currently we also provide the customized data reporting. The engineer can generate different production reports automatically, also support the data item customization, data query to different level, associate data query, switches between plot and report, extra. And the second case study is the geosteering. Exactly or technically, we call it the geoengineering. Today in China, the shale gas is becoming more and more popular. So the horizontal well monitoring and geosteering is even important for us. For the geologist and drilling engineer can collect the LWD, mud logging, well logging, and the drilling engineer data in field during the drilling to analyze the conditions of the reservoir quality, the drilling quality, and the completion quality. Okay, the last one, way forward. This meeting is called the Huawei Digital Transformation Conference. So as we all know, the digital transformation is so important for us. So currently, the Kunlun Digital Technology and the Huawei company are cooperating each other to develop a serious AI application. There are 4 layers here. The first layer is infrastructure. Of course, definitely, Huawei company provide the hybrid network, industrial sensors, industrial mobile devices, intelligence, cameras, and edge computing. And for the data lake layer, Huawei provide a cloud stack, for example, the fusion storage solution, data governance, and the Kunlun Digital Technology provide the different domain data asset from exploration to production. For example, Kunlun Digital Technology provide the public data, EMP technical data, and EMP model and management data. And based on the infrastructure and data lake, the 2 companies are trying to develop the AI series application. From Huawei side, provide the cloud AI services like the AI development tools, AI training framework, AI algorithm factory, or AI chips servers. From Kunlun side, provide the domain engines from exploration to production. So under the Huawei excellent support from hardware and software, today Kunlun Digital Technology already developed a serious AI application covered from exploration, development, drilling, production, pipeline, refining, and sales. So this is what we already done for the AI development, to better support integrated application and decision making. Here I list so many AI series apps, mainly cover the seven areas from upstream to middle stream to downstream. The purple color means already available. The blue color, we are cooperating with Huawei to develop together. Okay, that's all my presentation. Thank you for your attention. We are looking forward to cooperate with you everyone. Thank you again.
Thanks to Mr. Lu for his wonderful sharing, and thank you for watching. We also look forward to making more in-depth explorations and achievements in this field of intelligent oil and gas. More digital transformation pioneers and Huawei will continue to explore the smart world with you. Let's create new value together.